Alright, so we're going to go over chapter 24, and that's photoelectric semiconductors, fiber optics, and light-based applications. And kind of going to go through this fast, and then we're going to go over some more stuff that I didn't necessarily write down, but I'll just write it down as we go over it. So, electricity has been used to provide light, heat, rotational motion, sound, and other outputs for over 150 years. Photoelectric devices contain solid-state output switches, and it has no moving parts, so they have no moving parts. I know my pen's not dead. Cancel. I wonder if my pen's dead. This isn't my pen, this is Robbie's pen. He left his pen. No wonder it's not working. I was like, why is this not working? Okay. So, we're still talking about photoelectric devices. Alright. So, uses a triac SCR NPN transistor or PNP transistor. And the triac output used for switching AC loads. The SCR output is used for switching high power DC loads. Let's see. So solid state switches include normally open, normally closed, or combination switching outputs. Solid state devices are usually connected through the use of electrical devices. So they can be connected through light driven devices. So PN photodiodes, a diode with a large intrinsic region sandwiched between P-type and N-type regions, based on the principle that light radiation, when exposed to a PN junction, momentarily disturbs structure to a PN junction. Super interesting, right? So phototransistors, a device that combines the effect of a photodiode and the switching capability of a transistor. Light-activated SCRs, also known as LASCR, is an SCR that is activated by light, similar to photodiode, very low level of current. When triggered by light, provides complete isolation between the input signal and the output load current. Phototriacs are activated by light. The gate is light sensitive. It triggers the triac at a specified light intensity. In darkness, the triac is not triggered. Bilateral and designed to switch AC signals. Light emitting diodes, that's what we're familiar with, LEDs, is a semiconductor diode that produces light when current flows through it. As electrons move across the depletion region, they give up extra kinetic energy. The extra energy is converted to light. An electron must acquire additional energy to get through the depletion region. LED manufacturers normally use a combo of gallium and arsenic with silicon or germanium to construct LEDs. So LEDs can produce infrared light. So, do you know what infrared light is?
I know it's on the spectrum of something.
Yeah, so light we can't see because it isn't on the visible spectrum. And LEDs may emit a visible red or green light. Laser diodes are similar to an LED, but with an optical cavity that is required for lasing production, emitting coherent light. Optocouplers, an electrically isolated device that consists of an IRED is what that meant to say, but I just can't write, as the input stage and an NPN phototransistor as the output stage. Uses dielectric sandwich to separate input from output. The coupling medium between the LED and sensor is a transmitting glass. Let's see. Here. And so I was going to draw an optocoupler. So like, open that always switch. Match by the wavelengths for maximum transfer. Actually, I'm not going to do that. I was going to draw. So like for LEDs, since we're familiar with them more so than anything else. The symbol for an LED is this right here. Okay, it goes down. A negative sign and a plus sign. And you got two arrows going out like this. And just to like show how an LED is made up, because you don't think about it often, but those little LEDs that we mess with are pretty cool actually. So like you've got P-type material over here, and you've got N-type material. Why did I say nah? N-type material over here. And they're going to be negatives all over here, and these are going to be positives all over here. And this is what you would call your depletion region. This is what this is talking about. And right in the center, right here, is where it begins emitting light. So light begins emitting in that depletion region. Because that's like the neutral region. You get that, right? That's where all the electrons are like, that's where the kinetic energy is lost, the extra kinetic energy, in between the P-type and the N-type. And let's see, there was some other stuff I wanted to draw out here. We can just go into the next slide and finish off these slides. So this provides one-way transfer of electrical signals from the LED to the photodetector without an electrical connection between the circuitry containing devices. Photoelectric sensors, a solid-state sensor that can detect the presence of an object without touching the object. This sensor detects the presence of an object by means of a beam of light. So it uses solid-state outputs to control the flow of an electric current. So, kind of like your backup camera on your car. You know, that would use that because it's just a sensor of that light's bouncing off of that object and how fast is it bouncing back to the sensor, and that lets you know how close you're getting. But to me, that's pretty neat that it's in devices like our car, you know, machines like our car. Okay. Let's see. So we can get on into fiber optics because that's kind of more interesting than photo sensors and stuff. So fiber optics. And Robbie's the professional at fiber optics, not me, so. Oh. It's a technology that uses a thin, flexible glass or plastic optical fiber to transmit light. So like, you know, when we get our internet and stuff, you can get fiber optic cable and stuff. Says fiber optics is the most commonly used as a transmission link. It connects two electronic devices or circuits consisting of a transmitter and a receiver. Sorry about got choked on a Pringle. Alright. So you're gonna see this like Alabama Power, Pike, all of them have those telecom departments, and that's what they work on. They work on fiber optic cables and stuff. And I feel like soon that's all that there's going to be. Like there's not going to be, you know, lines, like power lines and stuff, like as in Wi-Fi and all that good stuff. Like it's all going to be fiber optic, like cell service, all that fiber optic cable and stuff. So it says communication is the transmission of info from one point to another by means of electromagnetic waves. So fiber optic technology has been developed to use light wave communication to transmit data. So it uses light wave communication to transmit data. And to be honest, that's where a lot of money, you're going to make a lot of money is fiber optics now. Because like telecom and stuff, they make really good money for like a lot less work, you know? Let's see. The light emitting and receiving components in fiber optics are located remotely at the housing of the control, while only the optical fiber cables are exposed to the severe environmental or hazardous areas. So, optical fiber exposed to the environment. So, they're located remotely. So the light emitting and receiving components located remotely. The central part of the transmitter is its source. The source consists of a LED, an infrared emitting diode, or laser diode that changes electrical signals into light signals. So, let's see, central part is the source. Source equals either an LED, and IRAD stands for infrared emitting diode, okay? IRAD or laser diode. And that changes electrical signals into light signals. Okay. So looking at optical fibers, what they consist of, they have a core, so they have a core, they have cladding, and protective jacket. The core is the actual path for light in an optical fiber cable. So the actual path of light. Is it not neat that cables in the ground deal with light? To me, that's cool, even though it's like kind of boring reading about it, but that's cool that it's in underground, but it deals with light.
Yeah.
So it can be made of glass, but may be constructed of plastic too. Cladding is the first layer of protection for the glass or plastic core of an optical fiber cable. So, protective layer for core. And the cladding is enclosed in a jacket for additional protection. So, this is just an additional layer of protection. Alright. Let's see. So, what two materials can be used for the core of optical fiber? What we just talked about.
Glass.
Or plastic. Yep, glass or plastic. And that might be on like a little mini quiz or something. Just whatever we go over, you can go back over this lecture video and look, and it should have, I mean, it should be like an easy grade for you. Okay, so this is a good one. So, the next question would be, why are signals sent over an optical fiber cable not affected by electrical noise, such as external magnetic fields produced by motors and other coils? And we didn't read about that, so
I think it's because it's under the ground even up.
yeah, I'm gonna try to read through here and find the answer. Affected by electrical noise. Alright. Let me just, okay, so the light emitting and receiving components in fiber optics are located remotely. Okay, so the optical fiber cables are not adversely affected by the electrical noise because they carry signals in form of light.
Oh, because
That's-
it's a whole different signal.
Yeah. Because the signals are carried in light forms. Alright, and talking about fiber connectors. I know I'm just blowing you away with all this information. So the ideal interconnection of one fiber to another is an interconnection that has two fibers that are optically and physically identical. So, two fibers optically and physically. Why does my hand keep doing that? Identical. Alright, these two fibers are held together by a connector or splice that squarely aligns them on their center axes. The joining of the fibers is so nearly perfect that the interface between them has no influence on light propagation. A perfect connection is limited by variations in fibers and the high tolerances required in the connector or splice. These two factors also affect cost and ease of use. Splices and fiber interconnections are often more of a negative factor than poor quality materials because of alignment problems that can arise, such as fiber gap, lateral offset, and angular misalignment. The elimination of alignment problems can be accomplished through proper installation of fiber splices, connectors, and couplers. So what are three problems that can occur and cause reduced data transfer in fiber optics? Transfer. So we just read it, and the answer would be fiber gap, lateral offset, and angular misalignment And that'll probably be a question on the test too. All right. See what we can talk about now. So let's see. So an example that it gives in the book of a photoelectric sensor, what we was talking about, could be in the backup camera of your car. It would be like a conveyor belt with cartons, and every time a carton would pass that conveyor belt, it would count it and stuff. So that would help you with inventory or whatever. Another thing would be like molten iron. It's getting poured into a vat, and the required fill level of that, like, because you know it would melt any sensor that it had besides a photoelectric sensor. So those are pretty good examples of that. So let's see. Photoelectric sensors. I know we're kind of jumping over the place, but they consist of two separate major components. One is a light source. And that would be a phototransmitter. Two would be a photosensor or a photoreceiver. All right. So scanning, that is the process of using a light source and photosensor together to measure a change in light intensity when a target is present in or absent from the transmitted light beam. So it's just going to basically, it measures a change in light intensity. Light intensity when a target is moved within the light beam. All right. And now I'm going to try to find some videos on how LEDs and photosensors work, because I feel like that would be more interesting to watch. Would you have to agree?
Yeah.
Let me just see if I can actually get on there while connected to that thing. All right, so let's see. All right, let's see if this is worth anything. Let's see if I can share it with that screen.
Chromebooks are seriously easy to set up, right out of the box. Just sign in with your Gmail and bing. All your files are right there. Now get out, because you're good to go. Switch to setting up the easy way. Switch to Chromebook.
Hello, I'm Simon Whistler. You're watching the Today I Found Out YouTube channel, and in the video today we're looking at how an LED light works. An LED, or light-emitting diode, is basically as the name describes. It is a special type of diode that is specifically optimized to give off light, usually in the visual or infrared spectrum, as electricity passes through it. A diode is a special type of semiconductor that has many uses. One of the principal uses, though, is to control the direction of the flow of electricity. The most common type of diode does this by using something called p-n junctions. This is just a fancy way of saying magic. Really though, in simple terms, think of a Dr. Pepper can divided in the middle. On one half, you have made a semiconductive material that you've added impurities to so that it contains negatively charged carriers, basically an abundance of electrons. We then call this side an N-type semiconductor. On the other half, you've done the same thing, except that you've introduced impurities that contain positively charged carriers. Basically, think of it like a bunch of holes that need to be filled by electrons. We call this side the P-type semiconductor. So we have one side an N-type semiconductor, and on the other side a P-type semiconductor. The boundary between these two is called the p-n junction. This is where the magic happens. It turns out that conventional current will travel from one side to the other, but doesn't like to go in the opposite direction. So you can use this to make sure electricity only flows in the direction you want it to in your circuit, among a lot of other things, because seriously, diodes are crazy useful in a variety of ways, and specialized diodes can do some other interesting things, which I won't go into in this video, but we might address at some point in the future. Generally speaking, these p-n junctions are at the heart of almost all semiconductor electronic devices. So how are these diodes modified to produce light? Well, it turns out they don't really need to be modified at all to produce a form of light radiation. However, standard diodes tend to be made of materials that absorb most of the light radiation given off, and more importantly, tend not to give off light in the human visible form anyway. What's going on here is, as the electricity jumps across the p-n junction, the electrons from the n-type fill the holes in the p-type side. During this process, the electrons end up changing their state. During this state change, a photon is emitted. More specifically, what is going on is as electrons move around orbiting a nucleus of an atom, they have different amounts of energy. Electrons with orbits farther away from the nucleus have greater amounts of energy. Electrons with orbits farther away from the nucleus have greater energy, and ones closer have less energy. So in order for an electron to change its orbit, it needs to either lose energy or gain energy. What we are interested in with LEDs are the electrons going from a higher orbit to a lower orbit, thus losing energy in the form of a photon of light. When the electrons from the n-type side fill the holes in the p-type side, they then lose energy in the form of these light photons. The greater the energy release, the higher the frequency the light photon given off, thus changing the color. If the frequency ends up being in the human visible spectrum, the range your eyes can see, then you'll see the light being given off by the LED. If not, such as when it's given off in the infrared spectrum, then you won't see it, but it can still be useful, such as allowing you to change the channel in your TV. Infrared LEDs are typically used in your TV remote control, among other places. When you press a button on your remote, you don't see the light, but the receiver on your TV can see it and can interpret what it's seeing from the infrared LED. In LEDs, the light that ends up being created depends then on the material being used and the current that runs through it. The light in a standard diode has the atoms arranged so that the electron drop in energy is very short, and thus the frequency of light given off is invisible to our eyes, rather it is infrared. So simply put, LEDs where you can see the lights are made of semiconductor materials that create a bigger drop in the electron's orbit so that the frequency of the photon packet comes out in the human visual spectrum. They can even be designed so that the amount of electricity flowing through them will actually change the drop, and so you can have a multicolour LED. So I really hope you found that video interesting. If you did, please do give us a thumbs up below. And
Oh, did that explain anything at all? Alright, so let's see. Let me go look up how do photosensors work. Gotta go. Okay.
See you tomorrow.
Alright, be careful.
Hey guys, we're giving away a ton of these DeWalt samples today. Just fill out our quick
Welcome to this module dedicated to XU photoelectric sensor technology. A photoelectric sensor is a piece of equipment used to detect the presence or absence of an object without contact, using a light transmitter and a photoelectric receiver. They are easy to install and configure. They enable non-contact detection and do not wear out. Through those features, phototechnology can be used everywhere. A photoelectric sensor is a proximity detector based on light beam emission and detection. The light beam transmitter, usually a light-emitting diode, emits a light beam. When an object goes through the beam is deviated. The light-sensitive receiver detects this deviation. In this example, the light-sensitive receiver detects the beam reflection. The photoelectric sensor makes the information of the presence or absence of object available for the automation system. Photoelectric sensors have a wide range of applications to detect presence or absence of objects, parts, people. They are commonly used in assembly lines, food and beverage processing, material handling, packaging, access control, mobile equipment. There are 4 detection modes: diffuse, background suppression, reflex, through beam. As already mentioned, the detection technology is based on the light beam emission and detection. The system has always 2 parts: the transmitter for light beam emission, the receiver for light beam detection. The light beam is emitted by the LED, light emitting diode. The lenses in front of the LED and the receiver focus the beam in order to increase the energy received by the phototransistor. Detection occurs when an object enters the transmitted light beam and, in so doing, affects the intensity of the light at the phototransistor, the photoelectric receiver. As the light intensity at the receiver increases, the output of the sensor changes state. It behaves like an electrical contact. The gain is the ratio between the received light energy and the necessary light energy to switch the product on. When the quantity of light is not enough, there is no detection. For a given application, a photoelectric sensor shall be adapted to the type of object to be detected. Whatever the size, the color, the shape of the object carried by this conveyor, it shall be detected. The photoelectric sensor shall also be adapted to the distance between it and the object to be detected. Whatever the distance between the sensor and the object carried, it shall be detected. But in this case, other objects outside the conveyors should not be detected. Not to mention that the photoelectric sensor shall be adapted to its environment. The environment light, for instance, or the presence of dust. A part of the light energy goes back. The orientation of the ray depends on the surface. If it is shiny, plain, and smooth, the incident ray is returned in only one direction. It acts like a mirror. If it is matte, the incident ray is returned in all directions. One part of the light energy can be absorbed. The energy is transformed into heat, for instance. A black matte object absorbs more energy than a white one. Refraction and dispersion. If the object is transparent, a part of the remaining energy is transmitted with a different angle depending on the material. To sum up, in order to be detected, the object must reflect and diffuse enough light. That's why White objects could be easier to detect than gray or black ones. Opaque objects are easier to detect than the transparent ones. The object can be detected if it is within a zone delimited by the sensing distance, which varies with the type of object, the environment, and the characteristics of the sensor, and the blind zone, which varies from 0 to 10 millimeters according to the detection mode. The object's shape can influence the direction where the beam is reflected. If the phototransistor does not receive enough energy, the object won't be detected. To be detected, the object shall reflect and diffuse enough energy to the photoelectric sensor. Regarding detection easiness, flat and concave surfaces are more favorable than convex surfaces. Environment conditions may impact the detection performance. Especially strong ambient light may blind the sensor, and dust may reduce the light intensity.
All right, so just to recap, I'm going to make a quiz, and it's going to be mainly based on LEDs and photosensors. So go back over this lecture if needed. It can be an open lecture. Quiz. For this week, we're just going to be building off of our VFD and PLC motor cabinet experience we've already got. So nothing really new to learn about those. Just go back over this lecture, rewatch it for the quiz. Any questions I asked in the lecture will be on the quiz. And if you have any questions, feel free to message me on Canvas. So all of this stuff that we went over will be on a quiz that I put up on Canvas. And basically just look at all the questions I asked, memorize the LED stuff specifically and the photosensor stuff. And quiz will probably be due within a week. So by next Monday, I'm sure that it'll be due whenever I can make it this week. So if you have any other questions, just let me know, and that should be it.